Okay, so if you look at the, just gonna, where am I here? There you go. Yeah, make myself look smaller. There you go. If you look at the core, our course portal, and if you go into the content section right here, and it takes a few seconds on my laptop here to populate. This bottom one here, it's a course plan, but it is from last year. All right. Now, the only thing that is going to change in that with that is pretty much the order of things. I always have to readjust the order based on the academic calendar that basically deviates slightly as far as dates, holidays, or things that have to do with the academic calendar versus the schedule of the whole class as far as the days of the week. So when you look at this, I have downloaded that. Where do I have it? Here. No, not here. Not here. Here. Course plan. Okay, so that's basically what it looks like. That's from 21. Oh my God. Where's my mouse? Here it is. It doesn't like white. Cat. Isn't that great? It just starts. There we go. Labs here. All right. When we talk about labs, we are going to start with the deliverables, and that will not change. So the first lab, and we will talk about that today. And then the next lab that we're going to do is going to be something that's called a PA system, which is not on the last year's schedule, but we will do the first. We'll do this lab as the first one. All right, and we will go over that too. But first, we're going to go over the whatever we have to do for the lab one. Now, lab one. It's called deliverables. Now, if you look at, where are we here? That's our playlist right here. Okay, I already populated that with 2 items. One is the deliverables, how to prepare. And it's an 18-minute video. Just watch that, and that is going to tell you everything you need to know as far as preparing deliverables. What are deliverables? It's a documentation that is required on completion on any kind of work that you do in the field, as far as installation, service calls, or whatnot. And you submit that documentation to whoever hired you to do this job in order to get paid. It used to be some time ago, before the internet was widely implemented, and yes, there was those times, sometime up till mid 90s or the end of 90s. Okay, so it used to be that you would just go to the office and receive a bunch of fax documents telling you where you need to go as far as service calls when it comes to the service industry in telecommunications, because this network cabling course is basically has to do with the service industry that has to do with the infrastructure as far as data, audio, security systems like alarms or security cameras, and anything else that has to do with that. We're going to concentrate on some things, like for example, we're going to concentrate on the data networks installations and understanding thereof. And we're going to concentrate a little bit on audio because these are the common things. I will touch up on the security alarms, fire alarms, and possibly maybe neuroskull systems, things like that, right? But mostly, uh, um, it is going to be the bread and butter of this telecommunication industry, as I'm talking about this network cabling infrastructures, is going to be most of the time you're going to deal with installing computer networks. I have a question here. The section 3 we have tomorrow canceled. Okay, so first, yeah, thank you for mentioning that. Okay, so this week labs are not going to be in class. Right? This week's lab is the first lab is deliverables, and you will do that on your own and submit those deliverables into the submission box that is not set up yet, but I will populate that tonight. All right, so it's just like I remember when you were submitting the assignment from the last term with the three-way switch. It's going to be on the same basis, except every lab that you're going to do is you're going to submit the deliverables, or otherwise called, in our situation, it would be the lab reports. Like in school, when you do labs, you submit the lab reports, either in person, hand in, or quite often you're going to do this online. So I'm going to, what I'm going to do is I'm going to, let me say, kill two birds with one stone. Basically, we're going to have the lab reports, but they're going to be in the form of work order deliverables. So you're still going to submit the lab, but it's going to be in the form of work order, which is what you're going to be dealing with if you end up in this type of service industry. All right. So when it comes to the first lab, you will do that at home. And if you look at this YouTube playlist that I already set up, watch this video. Also, you might want to quickly watch this one here. It's 2 hours, but if you speed up and skip some of that stuff, like for example, part of that is, it's from last year. Part of that video is the safety briefing that we have done already. So you might want to kind of, if you want to refresh that, by all means, please. But we already have done that. So you might want to kind of fast forward through that and watch everything else. So in that class, in that video, I'm going over the course plan. So it is going to be pretty much the same, except some of the order is going to change, and I have added one lab here now, which will be the PA systems. Right? Now, what we're going to do is we're going to perform 2 labs every lab session. We're going to split the class, and as soon as I get the clear vision of who is in what section, I'm going to divide you guys into the subsections. Like for example, section 1A and section 1B and section 2A, section 2B, and everybody's going to come every 2 weeks. Every 2 weeks, you're going to perform 2 labs. What does that go with is that I'm going to post the instructional videos on how to perform the lab, and you are going to have to watch those videos. Like seriously, if you don't watch those videos, you are going to be lost. And first of all, you're not going to get the full benefit of the class. And you might feel quite uncomfortable during that, because during the class, because I'm going to ask you to watch the video, the instructional, the demo video for the lab, just like last time, and you're just going to come over to the class, do the lab, and I will be just going over, giving you some pointers and correcting things and whatnot. So that's why we will be able to do 2 labs in one session, but you're going to show up every 2 weeks for your lab, right? So this way, we're going to be able to still perform 10 labs. It has been done in the last couple years due to COVID thing, and it actually works quite well. Right? So we're not going to miss any labs. You're going to perform 10 labs, and you're going to get the full benefit of that. So this is my my way of solving this thing here. So watch these two videos. Here's the deliverables on how to prepare, and here is the everything else that has to do with the course. And I'm sure maybe you're going to have some questions specific that will be specific to this year's course. Then we're going to take them one by one as they arrive. Now, when it comes to the labs, I'm just going to give you just a short overview. This thing right at all? I'm not sure. Let's see if this one writes. That's a little bit better. Okay. So every lab is going to consist, pretty much every lab is going to consist lab report or the deliverables. It's going to consist of 2 pages. Can you guys hear me? I'm getting some indication on. Okay, good. All right. So page 1. Come on. All right. Page 1. Yeah. Is going to be. Let's see if this one writes better. Is going to be the. My markers do not write. Let's see if this one writes here. Okay, this one writes. It is going to be the work order. Where are those work orders? And they're going to be you're going to have to print them, fill them up by hand, and take a photo and put that on the Microsoft Word. Where are those work orders? Here, I'm just going to go to the our class portal, and when you see that, you're going to see those student items there. So here it is. All right, and there are posted lecture notes, labs. You already have one there, and there's another item here that says blank work orders. All right. So if you look at the blank work orders, there are 2. One is the generic one that we're going to use for pretty much every lab except one. All right, one that says coaxial cable. There's the only different work order that goes with that. So it looks like this, and you can download those work orders and just, you know what, just print a bunch of them and have them in your binder, so you could use them as you please. Don't just print one by one. You are going to have to bring pretty much 2 work orders for every lab, since we're doing 2 labs every lab session. Okay. And we'll go over, actually, you know what, that video, the second video, it goes over the details of what's going on in those lab work orders. One thing I'm going to mention, there are those fields, all right? Field this, field that, customer's name and whatnot. And the second video goes in detail of what they are. Everything has to be filled in, all right? If there is some field that is asking you for some information that you just don't have because it doesn't apply to this specific work that was performed, just draw a line through it or say NA for not applicable. And this way you just show that this field was acknowledged. It was not left blank. All right. I'm trying to get you into a habit of reading things thoroughly. All right. Now, it's like, for example, this table at the bottom, you are not going to fill that at all, but I just want you to know that something like that exists, all right, when it comes to filling out the work orders. So pretty much you're going to have to either draw a line through every field, and there's 1, 2, 3, 4, 5, 6, 7, 8 fields. When you leave the fields untouched, I deduct marks. All right, so here's 8 fields here. If you don't acknowledge them, you're going to get marks deducted for 8 fields missed. right? Everything has to be acknowledged and something has to be put in there. If there's if the information applies to it, yes, by all means. Description of work on the bottom, I just left a little bit of space here because usually, unfortunately, that's what you get. So you're going to have to learn how to use some sort of like a point form. It's a bit of an art of filling out. Don't write a story, just fill out point form. And here is materials used. When it comes to materials used, do not list tools that you have used. Use only the billable materials. For example, cable or jacks, plugs, outlets, assemblies, and things like that. Whatever you have used, then you're going to put in, and you're going to say how many of that. We're going to walk you through that. Our first couple of labs, we're going to give you some suggestions. Then you're going to catch on, and it's going to just flow like a river for you, right? Okay, so that's the work order, right? Download it, print a whole bunch of them, have them in your folder, and just use them, right? If you don't, bring it. It's just like you showed up to work, not ready. You show up incomplete, right? And then after you fill it out, get the signatures. Of course, the first lab that you're going to do on your own, you're not going to get me to sign that or Mr. Habinsky. You're going to sign it yourself, right? It's just that first one, right? Photograph it, paste it onto Microsoft Word page 1, expand it to the point that it just takes the whole page, and that's it. Page number 2 of the work order is going to include 2 tables. I'll move my mouse. You don't see it, but I see it. All right, it just bothers me. All right, and they're going to be 2 tables. Table number 1, the bigger window, and the smaller window. And then a separate table number 2, just the same as table number 1, with the bigger window and the smaller window. Whatever the image you're going to ask to present, you're going to just put that image there, and another image, and you're going to describe it, just a short description of what it is on the bottom. Okay, that's it. So on the for the first lab, I'm going to ask you fill everything by hand. Description of work. Well, I'm going to ask you to photograph 2 images, whatever it is. Okay, it could be a pen, it could be a pencil, it could be an eraser, or it could be your favorite cat, or whatever. Okay, and you're going to put that in that first table, that image, right? And if it's your cat, you're going to say my cat, Willie, or something like that, right? And photograph another image. You could just photograph a stapler, all right? And you're just going to put that stapler right here, and you're going to write a stapler. I'm going to pay attention that the image is there, description is here, and description is here. It has to be on 2 pages. First page is going to be the work order filled out. 2 images. Don't make 3 pages with big images. I'm asking you to do 2 pages, just like this. And there's the step-by-step instructions on that YouTube playlist. Watch those 2 videos. All right. Now we're going to pay great attention to the detail of how it is done. And the reason is that I mentioned that on the video as well, but I'm going to say that again. When here's how it works in the real world, so to speak. Okay. If you work for some company, telecommunications company, installation company, whatever it is, right? Quite often that company is getting contracts from another bigger company. That bigger company has a certain way of documenting things, because that's the big company who actually hires the smaller company that you work for, who hires you. They are going to the big company is paying the smaller company, and the company you work for is paying you. They're going to pay based on the documentation delivered. So just imagine that there's a huge company that that basically takes care of a whole bunch of contracts all over North America, maybe some countries in Europe as well, or Asia, or Sometimes some of them cover the whole world. They have people in that company who receive the work orders from everybody who is submitting them. They want that thing to be submitted in a certain way. The way they ask, you submit that the way they ask. If you deviate from that by being creative, they are not going to like it. And they're not going to try to call you to say, because that's just impossible, because they receive a lot of those work orders per day. They're just going to reject it. So it might result in you not getting paid for your job, or your company who hired you not getting paid, and they're not going to like you. So just we're going to practice, follow the instructions. I'm going to ask you to do exactly as I say, not because I have some sort of an ego and I want it that way. No, I want to develop some good habits for you. So once you get into the work field, you are going to be comfortable with that. All right. Logistics companies only accept Excel files now. That depends. Here's how it is. Different companies have different systems. Some of them still use paper and they want you to submit, but that's an old way. Some of them use paper, but they are going to ask you to photograph as I'm asking you to do. And quite often you're going to get apps. All right, so you're going to be asked to perform pictures in a certain way, and the descriptions and whatnot, and you're just gonna go one by one by the field of the, and some of the apps are going to be on your tablets or on your phones, right? So, but we're going to have it this way. If you develop the good habits of following the instructions, then you're going to have the edge of maybe somebody else who is competing with you for the same job. Okay? Here's the reality of things, right? Plus, if you develop good habits, you'll be able to concentrate on other things instead of figuring things out how things are. Right? Okay, so that's as far as this goes. So that's the first lab. Do it. Watch those 2 videos. Download the lab instructions that are already posted on the in your class portal. Print the whole thing that you need. Do point by point. Do everything that it says. You should have no problem with doing this by now. All right. Now, on the video, I'll give you instructions of how to do it by using Photoshop and Microsoft Word. Right? It's the most standard way of doing that. There are some other graphic software applications that you can use. It doesn't matter. I'm just showing you this one way. You have access to Photoshop from our college. You have access to Photoshop by going into the computers that are on our college, or you can also download some of those apps like Photoshop and Microsoft Word. You should be able to have no problem having those. That's what we have. I'm showing you how to use this. If you have some other ways of doing it, that's fine, as long as I have, and here's the thing, as long as I have one PDF file consisting of 2 pages. I'm going to say it again. I need one PDF file consisting of 2 pages as instructed. Right? Do not send to me in Microsoft Word format, do not send other formats, PDF file. The reason why I'm asking for PDF file is that when I open that in FOL, PDF files are displayed properly. Anything else, even Microsoft Word, sometimes the display gets kind of finicky. So sometimes I won't be able to open it. And there's some other JPEG files or some other, there's some kind of an Apple related format. Those I can't even open at all in anything, right? So PDF files as instructed, all right? Now, so we have no, there's no class tomorrow, right? No labs. Now, when I say no labs, I'm going to have to specify for this particular course. No labs. I'm talking, whatever I'm talking about is just this particular. The reason why I'm saying that is that a couple of years ago I said no labs this week. So some people didn't show up for any other classes for the labs, and people said, "Did you tell them that there's no labs?" Yeah, but just for my course, right? I'm just talking to this course here. So there's no labs this week. No in-class labs, but I'm giving you the lab in the form of assignment. I always do that every beginning of the term because there's people still are setting up with things, and usually that creates a mess when it comes to people having things not complete, not being able to come to class or doing things a certain way. We have to practice how to do the deliverables because this is going to be part of every lab. It's going to take you one whole lab to figure this out, and later on it's just going to be a small part of every lab that you're going to perform, right? Next week there will be labs in person, yes, right? I'm still trying to figure out the sections or who's who in what section. Excuse me, and based on that I'm going to be able to set up a schedule, right? We're just right off the bat, New Year's, COVID outbreak again, and of course we're going to deal with that. Now it doesn't bother me with my course because I kind of anticipate that every beginning of the term there's always some slow start with people getting parts, tools, or whatnot. So I would just do it this way. We still have to do it. Good time to do it first, right? Cool. So again, I'm just going to say no labs in person this week. And there is going to be a deadline. You're going to have a week to complete this thing, right? And then when it comes to submission or submitting the work, your deliverables for every other lab as we go on, you're going to have pretty much a week to complete the deliverables, but don't wait a week, just do it right away, all right? But what we're going to do is in the work order, as we sign it, we're going to say do so-and-so at 11:59 p.m. Right? And if it's not done by that or later, you're going to get late marks. I assume there will be a submission folder. Yes, I'm going to populate the submission folder for that tonight, all right? So but tonight you probably won't be able to do it. You just still have to watch those two videos, right? All right. So and then this course plan that is in the content part of our class portal. It's last year's content, last year's course plan. It is going to be replaced with the current one as soon as I come up with it. As soon as I'll be able to figure the sections, and so within a week things are going to settle down. The dust will settle. Okay. So here is that. So don't come to the labs in class B1006 this week. Next week we start with classes in person as soon as we start set up the schedule. I think I'm going in circles. I think I was here before. All right. Okay, so the first, so that's going to be the first lab. The lab after that is going to be something that's called the distributed audio lab. And I'm going to start on that. It's 3:29 right now, so 3:30. I'm going to start on that. There are two sessions for the lab is called distributed audio, but it has to do with the PA systems per se. It's part of the PA systems public address. So we're going to start with that. Any questions so far?
Well, I do have one. So how come we're not? So I know if we're not coming to that lab this week, then what do we do instead at that time?
Oh, that's the lab that you do at home. Okay.
Oh, that's just the lab we do at home. And
yeah, it's called the deliverables.
And my other question is, so when it says, is it like any object, like photograph any objects? What do you mean by any object?
Any object. I mean, you could have a pen or a pencil or a remote control or your favorite pet or whatever. It's just
could it be like a television?
Yep, could be anything. Just we're practicing following the instructions. In the see what happens in the work field. You're going to
Yes.
ask because before some time ago there used to be that you just get a piece of paper, you do the job, you get this thing signed by whoever is receiving your job. So yeah, he was here, he did it. Okay, good, I sign it. All right, and that's what you submit to your boss, and your boss would submit wherever else. Okay, so that would be the old days. Now, when everybody's got the cell phones with the camera in it, so for some years right now, as soon as you perform some work, it could be a service call, it could be an installation, could be whatever you're sent to do, right? The companies that hire you, they request pictures of things, and not only they request the pictures, some of them they request the pictures done a certain way. Like for example, if you set up cash register at the store, a new installation, like a POS, point of sale, cash register. They're going to ask you to take pictures a certain way, from this angle, from that angle. Is this being installed here, there, and you just have to follow the instructions and give the pictures to them that way. Right, so that's why I'm asking you to start with that. We're just practicing the whole structure of things. Page 1, here's the work order. Page 2, table number 1, table number 2, picture description, picture description. You do that, that's fine. Fill out the work order by hand, photograph it, put it on the Microsoft Word, save it as one file, and then convert it to PDF, submit to the box. That's basically, that's the lab. That's the first lab. Okay? I just want you to get comfortable with that.
And the last question, and
okay,
yeah, and the very last question that I have is, so, what do you mean by, so what exactly do we fill in the table?
Oh, in the table, you are going to insert an image.
Yeah.
Here. Where's my pen that writes? Let's say here's the page, second page of that, and there's a table here. And here is, so the table is going to give you 2 rows, one bigger one smaller at the bottom here. And if you have a cat, so you're just going to have a cat.
Yes.
All right, here's the tail, and and you're going to say my cat. That's all I'm asking. Right.
Okay.
The next one is going to be something else, and then just write a description. I just need to have an image, and I need a description. And that's pretty much everything else when we're going to do the lab. Like for example, we're going to practice terminating Cat5e jack. All right, you're going to take a picture of the jack terminated, and you're going to write Cat5e jack terminated, something like that. Right?
Thanks.
No problem. You're welcome. All right. Okay, so I'm going to start you off with some things that we are going to perform this during the second lab. The second lab is going to be called, distributed audio. Now, distributed audio is when you went through, I'm just covering my microphone here. Let's say, remember in your high school years, when you went to high school, you would have those ceiling speakers in the hallways, and you would have that classroom speaker right in the classroom, the intercom thing. That's pretty much what we're going to practice doing the end of thing, the end part of things, which is the speakers. So these will be those ceiling speakers. It's called distributed audio. All right. So first thing I'm going to bring your attention to, have you studied anything that has to do with transformers yet? In your last term? Which would be coils, inductors, and things like that? No? Not really. Okay. So I'm going to give you a quick rundown of what transformers are. Right? And then we're going to go on with the, not sure, you probably won't have time to go over the PowerPoint presentation that I have, but you need to know the basics. All right. Now, if you have a conductor, right, and that conductor is Just lower the light a little bit so you can see things better. Grandma, why do you have such big teeth? So I can see you better. All right, and let's say this is some sort of a load here, and there will be a power supply. And this here would be a wire. Okay, so this is load. Okay, now let's say here this is the plus, this is the minus. Right, as well as battery. So the conventional current would flow this way all through this branch. So we have a current flowing through this conductor. Let's just look at this conductor here. When we have the current flowing through this conductor, we're going to have something that is called an electromagnetic field, right? Which is magnetic field caused by electricity, electromagnetic field. And it's just like a corkscrew, right? When you have a corkscrew, you turn it, it goes that way. So this would be the turning direction, yeah? And this would be the current flow. So this is the current flow, and the way this corkscrew is turning, if you drink wine, is going to be the direction of the magnetic field. It works better with the AC, right? AC, because the current goes back and forth. But let's say if we're just going to take one instant of the current, because at any given time, the AC is just like DC. At any kind of, if you stop, if you make if you just pause things, if you pause the reality, you're going to catch the current flowing a certain way at any given moment. So that's why I decided to put a DC. So here's the longer prong, shorter prong, some plus and minus. Now at that point, there's a current flowing through the conductor, and there's a magnetic field, electromagnetic field surrounding that. Follow me so far? Now, if you place another conductor beside this conductor, I need some new markers. If you put another conductor here, and let's say that's going to be some other load, yeah. So you just placed another conductor in proximity to that conductor. That electromagnetic field is going to affect that conductor, and is going to induce a current flow in this system, even though there is no battery in it, there's no power supply in it. It's called induction. So first system here, you have a current flow which causes the electromagnetic field, and if you put another conductor in proximity with that electromagnetic field is going to make the current flow in the other system here. So that's the principle of things. Now, how much time do we have? Do you have another class after this? Just so I know. We have 2 more today. Okay. Is it like right after, back to back, after this or not? No. Okay, good. So sometimes if I go like a half a minute over time, nobody's gonna panic, right? Cool. All right. So let's say you have a coil. And you're going to supply AC current through that coil. Remember, when you have the current flow at any given time, the current is going to flow a certain way, either this way or that way. But AC is going to just make the current flow back and forth, because that's the idea of AC, alternating current. But if you stop the reality, if you pause the reality, you're going to catch the current going a certain way with a certain strength. So you're going to have the electromagnetic field around the conductor. Now, if you wind this thing, the conductor, you're going to have the magnetic field happening, strong magnetic field going through that. And it's just going to go. It's going to create north and south. One way if it flows, and it's going to create north and south the other way if it flows the other way. So that's going to be the magnetic field that is going to be created in the inductor here. All right? It's going to be a strong magnetic field. If you put another coil beside that, and if you put a voltmeter here, you're going to notice that even though these are not physically connected, that first coil is going to induce current flow, or also voltage. If this is open circuit, is going to create a voltage in the other coil. Yeah. Now you can do the transformer. That's basically the idea of transformer, how it works. You can do it by putting those coils in a close proximity to each other, or you can wind them on top of each other. Right? So you can wind, you can have one coil here, and you can have another wire that basically is wound with it, right? And here, and you're going to have a voltmeter here. If it's a 1-to-1 ratio, if so many wounds here, and if it's a 1-to-1 ratio, you're going to have the same voltage as it was here. Now, here's the interesting part. If, let's say you have 200 wounds on one coil, and you wind it with the other, just half, maybe 100 wounds, then things are going to be different. If you have 100 volts on the first one, and if you just have half of the wounds that the first one is, the second one is going to be the half of the voltage. That's how you do the transformers with the ratios. Yeah? So that's one thing that you know about the transformers now. It's just a very basic concept. Yeah? The current happens through induction. Now, transformers are so efficient that, here's the key thing about the transformers, they transfer power. Whatever the power comes on one coil, it is going to induce the same power on the other coil. Now, when it comes to just RMS values, power equals to voltage times current. Okay. We got the phone ringing. Phone is ringing, phone is ringing. Right. So the power that is going to be injected into one winding, it is going to leave through the other winding without being physically connected. How is this going to happen? Through the induction that I just explained to you. Now, in order for the transformer to convey the power, it has to transform things. Remember when I said that, let's say you have 200 wounds on the first coil, and you only have 100 wounds on the other coil, the voltage on the second coil is going to be half as much as the voltage on the first coil. But what do we have to do to keep the power? Well, if the voltage goes down on the second coil, in order to keep the same power, the current has to go up. Or if the voltage goes up, then the current has to go down. If you increase the voltage on the winding of a transformer on the coil, you're going to decrease the current, because this power has to be kept. If you increase one, you have to decrease another, so the product of that is going to be just the same. So The transformers transform voltage. They also transform current, but they keep power. Right? Now, there's another thing that the transformers transform, and it's something not called impedance. Did you guys study what impedance is in any of the other courses? No. Okay. Well, what's an impedance? Impedance is a combination of resistance and a reactance. Right? What is a resistance? A resistance is a passive quantity that resists the flow of the current. And it's found in a simple resistor. Yeah. Resistor has a resistance. And it doesn't matter what you do to it. You put more current, more voltage, whatever, its resistance stays the same. If it's a 20 ohm resistor, it is going to be 20 ohm resistor no matter what you put through it. Whether you put AC or DC or whatnot, it is going to have 20 ohm resistance. If it's a 600 ohm resistor, it is going to be 600 ohms no matter what you apply to it. It's going to resist with the value of 600 ohms. Right? It's a DC kind of a related quantity, resistance. Actually, if you put the AC through it, also it's going to have 20 ohm or 600 ohm or whatever it is rated, or whatever how it's made, it's going to stay no matter what. Now, there's another thing that is called reactants. Reactants, I try to always explain, it's a reactive resistance. Depending on what you ran through the device that has a reactance, it is going to behave a little bit different. Like, for example, a coil inductor. Right? Inductors do not like change. If you have certain current flowing through it, AC or DC, it is going to try to, well, DC for example, it is going to, as soon as you connect that, initially there is no current flow in it. As soon as you connect the DC power, for example, it is going to try to oppose the current flow. So it's going to create a voltage that is going to oppose the current flow. But if you plug it in and you keep it that way, then it's going to adjust and it's going to start conducting again when it comes to DC. Now, so DC is basically a zero frequency. There's no frequency, it's just a DC. There's a plus, there's a minus. Well, another philosophical way of looking at it is what's a DC? It's a combination of all frequencies that exist together, so they're so thickly packed that it actually becomes DC. But I'm not going to get into that. So let's say DC has a 0 hertz frequency. Now, when you start altering the current, right, plus minus, plus minus, plus minus, plus minus, so the current is going to flow like this. If it's just changing slowly, right, then the coil is going to give you not much of a resistance. The slower you change, the less resistance, the less the coil is going to react, the less of a reactive resistance is going to have. As soon as you start changing the polarity quicker, which means you're going to increase the frequency, you're going to make the coil not like it, because coil doesn't like change. It's going to start opposing more. So the bigger the frequency you apply to the coil, the more resistance it is going to get. So impedance, or the reactive resistance of the coil, depends on the frequency. It reacts to whatever frequency you apply, is going to behave differently. reactive resistance. If you apply 20 hertz to a coil, it's going to resist a certain way. If you apply 1000 hertz to a coil, it's going to resist more, which is the opposite of a capacitor. Capacitor likes change. The more frequency you apply to a capacitor, the easier it's going to conduct, right? But we're talking about the coil. Now, let's say this is a device that has certain inductance and certain resistance, and maybe certain capacitance. Everything has certain every little physical thing that works with electricity. It does have a resistance, it does have inductance, it does have capacitance. It's just what it has more, how it is designed. The resistor, pure resistor, in reality, it has a little bit of inductance in it. It has a little bit of capacitance in it, but those two, capacitance and inductance, are so small that they're actually insignificant. Because the resistor is made as a resistor, so the resistance, pure resistance, is the dominant feature of the resistor. If it's a coil, it has a little bit of resistance because it's made of a physical thing. Every wire has certain type of resistance. If it's just a plain old wire, it's going to have very little resistance, but still it's going to have some. It is still going to have some capacitance, act like a capacitor, but the resistance and the capacitance of a coil are so small that they're insignificant because the dominant feature of this coil is inductance. Same thing with the capacitor. Capacitance is the dominant feature of that, right? Okay. So, what's impedance? Impedance is the combination of, and how is going to, we're going to go a little bit over it a little bit in more detail when we talk about the coaxial cable, right? So the impedance is the combination of the resistance and the reactance, whichever it would be. It could be a capacitive reactance, it could be inductive reactance. Of course, in the coil, we have inductive reactance. So the impedance of a coil is going to be pretty much a combination of its resistance and its inductive reactance, and that's impedance. Now, if you have more complicated circuits that consist of a resistor, coil, capacitor, and some other things, then you're going to have to take them one by one and add them together to get the total impedance of the system, right? So, but that's basically, long story short, that's what impedance is, right? So, here's another feature of the transformer. Transformer conveys power. Whatever power comes to a transformer leaves. That's what's so wonderful about transformers. Increase the voltage, you decrease the current to keep the same power. It's just nothing escapes nature of things. Right? You increase the current, you're going to decrease the voltage, depending on what you want to do with the transformer, depending on what you want to accomplish. But it also, so it keeps the power, it transforms voltage, it transforms current, and it also transforms the impedance, which is indicated by the letter Z. All right, voltage with the voltage with the V, current with amperes, volts, amperes. Z is the impedance, and it is indicated by the ohms. Resistance is in ohms, and the impedance is also in ohms, except it has a little bit different characteristics. Impedance has an angle. I'm going to explain this thing to you in further detail when we get to the coaxial cable. Okay? So here's the thing. We got a couple minutes. I'm going to start you up on the You're going to start your thinking gears in a certain way towards that something that's called a distributed audio. Because why would I want to talk to you about that if I'm not going anywhere with it, right? I'm going somewhere with this here, okay? It's not drying fast enough. Okay. So let's say we have an output of an amplifier. Here's the amplifier. Here's the input, here's the output of the amplifier. We can connect, and of course there is, to complete the circuit, there's going to be some return pathway to the amplifier, but that's a symbol of the amplifier. Right? Connect that to a speaker, and you're going to have complete circuit. Let's say that output impedance of the amplifier is 8 ohms. In order to have the maximum power transfer, whatever power leaves, you want that power to be dissipated as much as you can through the speaker, you have to match the impedances. So that's why the 8 ohm amplifiers, they like 8 ohm impedance of a speaker. 4 ohm amplifiers, they like to see 4 ohms at the output. This way, the whole power gets through. If you mismatch the impedance, you're not going to be as efficient as transferring the power. So some power is going to be conveyed to the speaker, and some power is going to dissipate in heat, usually in the amplifier. Now, if you want to connect a bunch of speakers, you have studied the series and parallel connections of resistors. I'm pretty sure in the DC circuits you have studied the combination adding resistors, for example, series and parallel, right? Yes, good. Oh, there's a question. So impedance is just a reactive resistance. Reactants is reactive resistance. Now, because every component has a little bit of a pure resistance and a little bit of a reactance, you combine them two, you get something that's called impedance. Because it's going to have some resistance that's going to keep no matter what, and some of its resistance is going to keep changing. So it depends on the frequency that you apply to it. Okay. So if you have 2 speakers that you need to connect, and those speakers have 16 ohms each, and the speaker, the amplifier wants to see 8 ohms. What do you do in order for the amplifier to see 8 ohms still with the 2 speakers that have 16 ohms each? Any ideas? What do you have to, how would you connect those 2 speakers? Connect them in parallel. Yes, there we go. All right. And these are 2 16 ohm speakers, right? But what if you have 8 speakers, 4 speakers, 8 ohm each. 8, and here's 8, and here's 4 of them. What do? You connect these 2 in series. You're going to get 16 here because you add them in series. You add those 2 in series, you're going to get 8 ohms. So 8 ohms, 16 ohms and 16 ohms because you add them in series. And those 2 systems that you add in, you connect them in parallel, you still get 8 ohms. You can do that till the cows come home. You can do that with 100 speakers, connect them series parallel combination, and you're going to accomplish 8 ohms. But it's not a very efficient way of doing things. Because if you have a building that you're supposed to supply with the distributed audio, like 200 ceiling speakers and so on, you are going to, if you're really stubborn, you can connect those in the in series parallel connection that you're going to accomplish the impedance that is required that is required by the amplifier in order for the whole power to basically be utilized. Right? Not a very efficient thing. What if you want to add one more? Well, then you're going to mess up the whole system. You're going to have to redesign it again. What if you did that and came back 6 months later? Are you going to remember what you did? What if somebody messes up? You're going to try to figure out. It's not a very efficient way of doing things when it comes to commercial installations. One last thing I'm going to leave you with. How is it that this problem is solved, or this issue, or this challenge? How is it that is solved? One last thing, and I'll let you go. Now this is recorded, and I'm going to put it on our playlist so you can rewatch it later. Let's say there's an amplifier and it has 8 ohms. Now you're going to connect a transformer to it. There will be a transformer, and there will be a transformer here. It is going to be a step up. Step up transformer. Physically not connected, by through induction, because it's an AC signal, it is going to convey the power. So of course it's going to raise the voltage because there's more wounds here, so it's a step up transformer. And you're going to have one main line going through all the hallway. Okay. Now, if you get the ceiling speakers and so on, just keep going with that. If you connect that 8 ohms here, 8 ohms here, 8 ohms here, you're going to eat up the resistance capability of that, or the conductivity of this whole system, then you're going to drain the whole thing, and that thing's not going to work. It's just, but if you put something that is step down transformer at every speaker, and then connect, just tap into the main line, you can keep adding it, because while you're using the transformers, the step down, so first you step up and then you step down for every speaker. Then the impedances are going to adjust, because then it's a low impedance, 8 ohms. Here's a high impedance. The impedance is being transformed. The voltage being raised. The current is getting less. Then there's going to be a high impedance here and low impedance here. We are matching the impedances through a transformers, because the transformers keep the power, but they transform voltage, they transform current, and they transform impedance. So the impedances are going to adjust. So depending on what the windings of these transformers are, the speaker is just going to take as much power as it needs, and that's it. And you're going to connect the next one. You can just keep connecting those all in parallel. And if 6 months later you need to add 5 more speakers, yes, you can, by doing this, something that's called a distributed audio system. Okay. So that's what I'm going to leave you. Now, this is just a simple way of doing that, and you can do that. What we're going to look at later, tomorrow, or whenever it's the other session is here, we are going to look at something that's called the taps on the transformers. Basically, what it is, if you have the primary winding and if you have the secondary winding, you can feed that transformer with power, and you can pick up the power on the other side of the transformer, but you can have taps. So if this is your common right here, you can just use so many windings here. So this transformer, you're making another transformer out of that one. and you're going to have less windings here, so less power is going to go through there. Then you're going to do this, or less power, less voltage, then more voltage, and they're going to hold 1-to-1. Right? So that's why we're going to talk about the taps, because the transformers here, you can adjust the volume that is going to be pumped through these speakers by tapping it using different taps. Those step-down transformers, they do have taps. Okay? And that's pretty much all I want you to know at the first time that we get introduced to that distributed audio. What we're going to do on the second lab, during the second lab, is we're going to connect. We're going to have a main line from the amplifier that is connected to a transformer, and those PA amplifiers, those distributed audio amplifiers, they have those transformers built in them. Right? You can just connect right to the amplifier it has inside. Or if it doesn't, you can buy an external one, and you can do a regular amplifier thing. We're going to connect, we're going to tap into the main line that we're going to have going around the countertop, the long countertop. We're going to tap into a volume control, which is basically a tapped transformer that by clicking the volume control, you're selecting different taps on that. And out of that, we're going to take those wires and connect it to the speaker. So you can have that main audio line going to a volume control. You can control that, and you can send only so much volume onto the specific speaker. So all the speakers can be in the hallway. This could be somewhere in somebody's office, so they can adjust the volume for themselves. Right? That's what we're going to connect, and we're going to go over that. But we still have the week of doing the first lab right now. Right? Okay, cool. We got 7 minutes overtime. I hope you enjoyed this, and I hope you have learned something already with this. And I will see you. Here's my famous line. I will see you when I see you. And I'm going to look at my schedule because it's all new. It's New Year's. Cool. All right, guys. Yeah, take a break, Bach. Yeah, I'm going to take a break. I had a long break. Cool, guys. Thank you very much. And if you have any questions, by all means, email me, and I will do my best to answer that. Thank you. Have a great one. Take care. Bye.